In this problem we have a submerged piece of wood, and that piece of wood is going to be 0.15 meters by 0.035 meters in cross section. You can see the total length is 10 meters. What we want to do is determine the specific weight of the timber and the tension in the rope. Now you can see there's a rope down here. That's what's attaching this wood to the bottom surface. First, let's go ahead and draw our free body diagram and see what we have. So here is our line that represents the piece of wood that we're dealing with. This is at some angle alpha, whatever that may be. And let's put our forces on here. We've got a rope, and that's going to provide a tension. Tension is going to act down. Right, so we have our capital T. And then we're going to have two more forces. We've got the weight of this board, so let's call that W. And remember, the weight of the board is going to act at the center of the board. So the total length of the board is 10, so that means that this weight is going to act at 5 meters, measured from the bottom. Okay. Now we're also going to have the buoyant force provided by the water. Now that one, let's just put right here. And that's going to act upward. Now we need to know where that acts. That is going to act at the center of the piece of wood that is submerged under the water. So you can see from this drawing that 8 meters of the board is submerged under the water. So this distance here is going to be 4. So for the buoyant force, we only care about the part of the wood that is underneath the water when you're doing this measurement. Okay, so we've got 3 forces: tension, weight, and then the buoyant force. Let's go through and try to solve those. Now, here's our equation for the buoyant force. We've got gamma, and the gamma is going to be for the fluid that you are submerged in. So in this case, we have water. And that was provided, it's going to be 9,800. We're dealing in SI units. And we have gamma, and then times the volume of the submerged piece of material. Okay, so let's calculate what we have here. So our buoyant force is going to be the gamma of H2O. I'm going to plug the value in later. And then our volume that is submerged is going to be the 0.15 times 0.35 times the length that is underneath the water, which is 8. Now if you multiply all that together, you're going to get 0.42 gamma H2O. Okay, so there's that. Go ahead and write that down over here. And like I said, in a minute we'll plug in gamma H2O. Now let's look at this weight that we need to find. So our weight, that's where we're going to basically get in the gamma of the timber. Because remember, we're looking for a specific weight, that is gamma. So let's write the weight as the specific weight of the timber. So gamma sub T times the volume. Alright. So for this one, for our volume, we're going to have the 0.15 times the 0.35, that's the cross-sectional area, and now we want the weight of the entire board. So now we're going to put times 10, okay? So because again, we're finding the weight of the whole board, so we don't care how much of it is underwater or not. We want the entire length of the board, okay? Now if we do gamma times volume, that is going to give us a weight. So multiply all that out, we're going to get 0.525 times gamma sub T. Now this gamma sub T is what we're looking for. So that gives us this. Okay? Now what we're going to do is find a moment. We have point A down here at the bottom where this cable is attached, so let's find the moment at point A. If we do that, that gets rid of the tension force that's unknown at this point, and then that'll just leave the 2 forces. We'll say counterclockwise is a positive moment. And again, we want the summation of the moments to equal 0. Alright. So let's start with the weight first. That's going to be a negative moment because it's going to be clockwise. So we have negative 0.525 gamma T. And then we need a distance. That's a vertical force, so we need a horizontal distance. The horizontal distance will be 5 cosine alpha, whatever alpha is. Next, let's look at the buoyant force. That's going to be a positive moment. Whoops, let's erase that. So we're going to have plus 0.42 gamma H2O. And we need another horizontal distance, so that one's going to be 4 cosine alpha. And then that needs to equal 0. So if you multiply all of this out, and then we plug in gamma H2O because we know what that is, we're going to end up getting 2.625 times gamma sub T equals 1.68, and then plug in the 9800 for gamma for water. And what that gives us is a specific weight of the timber of 6,272 newtons per cubic meter. So there's the first part of our answer. Alright, so now we found that. Now we also want to find the tension in the cable. And that'll be simple to do now that we've found this gamma sub T. So the way we could do that, the easiest way, is going to be to just sum up the y components of force. Right? So let's say up is positive. Again, we want that summation to equal 0 because we want this to be in equilibrium. So now if we do that, we'll have negative tension plus 0.42 times gamma of H2O, and then minus the 0.525 gamma of timber. You can plug in your numbers for the gammas. So for water we have the 9800, for the timber we have the 6272, and if you plug that in and then you can solve for tension, you'll get 823.2, and that's in newtons. Alright, so the important things to remember about this problem, first of all, is this gamma is going to be, for the buoyant force, is going to be the gamma for the fluid that you are submerged in. Okay, and when we find weight, just like we said in this problem here, you care about the weight of the whole object. It doesn't matter what's on top of the water, what's below the surface of the water. You want the entire length when you calculate the weight. Okay.